2018 Leaving Cert Statistics short question and a long question this year. We're told the shaded area is 67% of the data. So you know that you're going to get a Z-score that's going to give 0.67. So if you go to your Z-score tables, your Z-score for 0.67 is equal to 0.44 exactly. 6700 is 0.44. Nice easy start. Now the percentage results for a maths exam for a class had a mean of 70 and standard deviation 15. So mean of 70, standard deviation of 15. Write down what you're given and it should appear to you what to do. The percentage results in an English exam for the same class had a mean of 72 and a standard deviation of 10. The result in both exams were normally distributed. Mary got 65 in maths, 68 in English. 68 in English and 65 in maths. So we're going to have to compare these two, which is better, relatively speaking. So it's just a one sample Z-score. So let's look at maths, one sample Z test. Maths, we're testing 65 against 70. And we're dividing by 15, which is equal to minus 5 over 15, which is minus 1 over 3, or minus 0.33. And for English, we're testing 68 against 72 with a standard deviation of 10, which is minus 4 over 10, which is minus 0.4. Well, which is better? Which is closer to the average is what we're looking at here. So minus is in this direction as the minus. So let's say that's minus 0.33. Minus 0.4 is to the left of that. 0.4. So therefore, is it maths the one on the left? Maths is the better result. Maths is closer to I suppose middle of normal distribution, is one way to say it. You could go to the Z-score table and get a value for each of these and show where they are, how much better they are percentage wise than other people, but this is good enough. You could also just say minus a third is greater than. We want, what have we got? Minus 2 over 5. I think we got 4 over 10, 2 over 5. That's another way to say it, to justify it. So that was parts A and B. Now part C and D look like this. In English, the top 15% of students were awarded an A. So that's a normal distribution where 15% is in the tail. So we want a Z-score that represents 0.85 here, 85% to the left. So that's what our Z-score is. So we're testing what did they get against the average. In English we're dealing with, just be careful, we're dealing in English. So the average in English was 72 divided by your standard deviation, which was 10 in English. That has to be equal to my Z-score for 85%, 0.8849 is 1.2. That's pretty close, so you can't get really close. 8849 is 85 we're looking for, not 89, 85. Z-score of 1.8, 1.04 is 8508. 1.04, it's going to be close enough, it won't change the overall here. So we're going to be saying 10 by 1.04, 10.4 plus 72, which is 82.4%. And we're looking for the least whole number, so that's why it wouldn't have mattered here. The least whole number is going to be 83%. So if you rounded off the Z-score slightly here, it wouldn't have mattered. Using the empirical rule, okay, are 68 or otherwise 68, 95, 99.7 for my 1, 2, 3 standard deviations. Estimate the percentage of students in the class who scored between 52 and 82 in English. So a sketch will always tell us where everything is. So we had our average in English was 72, straight line, 72. We're testing between 52 and 82. So easy enough. 82 is 1 standard deviation above the mean. And that 68% is 1 standard deviation above the mean. So that guy in there is 34%. And then to the left, 52 is 2 standard deviations below the mean. And 2 standard deviations is 95%, which would give 47.5% either side of the middle. So we've 34% and 47.5% is going to add up to 81.5%. 81.5%. When you know this empirical rule, really straightforward.